With over 200 AWS services available, it can be overwhelming when you're just starting out, or even if you have some experience in the cloud. I get it, because I faced the same challenges. When I started my journey, I'd watch one tutorial recommending a specific approach, only to find another expert suggesting something completely different. It was confusing and frustrating. Now, over the past decade of working in tech, I've gained extensive experience across multiple roles: cloud architect, cloud engineer, software developer, and DevOps. Today, I run my own cloud security consultancy, and this has given me a unique perspective on how AWS services actually fit together in real-world applications. Now, what matters is practical experience and understanding how to make architectural decisions. And here is what I've noticed. Whether I'm answering questions that my students have, former colleagues, or just people interested in the cloud, they are not only confused on what they need to learn, they want to understand how these services work together to build actual solutions that solve problems businesses are facing. And that's why this video is different to the ones I've done before. So go get your notepad and get ready to learn. Now, instead of just telling people to learn AWS S3 or SageMaker, I'm going to explain how these services fit into the bigger picture. We'll cover the core IT fundamentals that every engineer needs to know first. Then we'll go over the services that are actually being used in production environments. And more importantly, I'll walk you through the decision-making process that cloud architects and engineers use when designing solutions. Because while AWS offers hundreds of services, there's only a core set that you'll use consistently in your day-to-day work. By the way, join over 10,000 engineers accelerating their cloud career and grab my beginner's guide to the cloud for free, link in the description. Let's start with the absolute basics of how the internet works with some core AWS services to give you a big picture understanding. So every single device connected to the internet needs what we call an IP address. This is fundamental to everything. Now, when we talk about IP addresses, we're actually dealing with two types: IPv4 addresses and IPv6 addresses. Now, we created IPv6 because we started running out of IPv4 addresses as the internet grew. Now, since these IP addresses are just numbers and humans aren't great at remembering them, we use domain names instead. This is where DNS, domain name system, comes in. And specifically in AWS, this is what Route 53 service does. It converts friendly domain names into the IP addresses that computers understand. Now, when you're using the internet, whether you're loading a website or sending an email, everything starts with packets. And this is important to understand. Data isn't moving as one big chunk, so your email will be broken down into small pieces called these packets. Now, each packet will carry both your actual data and crucial information like where it's going, the destination IP, and where it came from, the source IP. The system that manages all of this is what we call TCP and IP. TCP handles breaking down your data, making sure it arrives correctly, while IP makes sure it gets to the right destination. Now, in AWS, networks have both public and private spaces, and understanding this is key for building secure applications. When you create your network in AWS, what we call a VPC, you'll divide it into different sections called subnets. The way you configure these subnets determines what can talk to what, and more importantly, what can access the internet. Think about what different parts of your application needs. Your web servers need to accept traffic from users on the internet, so your web servers need to go in the public subnets. These public subnets have a direct connection to the internet through something we call an internet gateway. This means users can reach your website, but it also means you need to be extra careful about security. But what about your sensitive resources like your databases? You don't want these directly exposed to the internet. That would be a security nightmare. That's why you put them into a private subnet. And these private subnets have no direct path to the internet, which means no one from the outside can directly access your resources. However, resources in private subnets can still reach the internet when they need to, like for updates, through something that we call a NAT gateway. Now, to control traffic within these networks, AWS gives us two powerful tools: security groups and network ACLs, also known as NACLs. Security Security groups control traffic for individual resources like your EC2 server. When you set up a security group, you need to specify exactly what kind of traffic can reach that server. It's like a web firewall over your EC2. For a web server, you typically allow HTTP traffic on port 80 so people can access your website, HTTPS on port 443 for secure connections, and maybe even SSH for port 22 to manage your server. But you can make it as restrictive as needed. Maybe you only want to use HTTPS traffic and SSH access from your home IP address. Now, NACLs or network ACLs work one level above. They control the traffic for the entire sections of your network, i.e. your subnets. The key difference is that NACLs can explicitly block traffic that you don't want, while security groups can only allow traffic. This gives you two chances to control the traffic, first at a subnet level with NACLs, and then at the individual resource level with your security groups. Together, they help you build multiple layers of security, making sure only the right traffic gets to the right places. It's all about having precise control over what can communicate with what in your AWS environment. So let's see how all of this works together. When someone types in your website address, the first thing that happens is the route 53. AWS's DNS service converts that web address to an actual IP address that computers can understand. Your static content, things like images, JavaScript files, and CSS, is stored in S3 buckets, and don't worry, we'll dive deep into what S3 buckets are for. For now, just know that's where we store static content. Now, these files get served through CloudFront, AWS's content delivery network that keeps copies of your content in data centers around the world, making everything load faster for your users. From there, dynamic requests go to something we call an elastic load balancer, an ELB. Now, the ELB's job is to distribute all incoming traffic across multiple servers. This is crucial because if one server gets overloaded or has problems, the ELB can send traffic to other healthy servers instead. Now, your application keeps running smoothly, even if individual servers have issues. And the really powerful part is how AWS handles growing traffic. We're using services like auto-scaling with your ELB. AWS can automatically create new servers when you need more capacity and remove them when you don't. You don't even have to manually manage this. AWS handles it based on the rules that you set. Now, your actual application servers might be sitting in a private subnet for security, but they can still reach out to the internet when they need to, like for updates or to talk to other services through a NAT gateway. Now, these servers can pull additional content from S3 as needed while staying secure behind your private network. Now, what's interesting is that all of these services are built on top of the networking fundamentals that we talked about earlier: IP addresses for identifying resources, DNS for finding them, and ports for controlling traffic. Now, each AWS service solves a specific piece of the puzzle. S3 handles your file storage. CloudFront delivers content quickly. Your VPC provides network isolation, and the ELB distributes traffic. This is why understanding these core networking concepts is so important. Whether you're building a simple website or a complex application, you're always working with the same fundamental building blocks. The tools might get fancier, but the underlying principles will always stay the same. And now that you have this fundamental understanding with the overview, and I've actually mentioned some of the AWS services, I'm going to use that example of how a website actually works and build on it by splitting that journey into 6 parts. And we'll delve deep into the AWS services that every engineer must know. But just before we get into that, if you're looking to switch to the cloud, then check out my Cloud Engineer Academy. I'll take you from zero to job-ready cloud engineer in just 12 weeks. Don't just take my word for it, go check out Jay's story. He went from banking with no prior IT experience to cloud hired in just a few months. Link in the description. So let's start with part 1, static content hosting and delivery. When someone types your website address into the browser, where does all of that content actually come from? Well, it's at the heart of most AWS platforms, and that is S3, Simple Storage Service. This is where all of your website files live: every image, every HTML file, all your JavaScript code, your CSS styles, literally everything that makes up your website. S3 organizes these files into what we call buckets, which are like the root folders of your website. S3 has been around since AWS began, and there's a good reason for that. It's incredibly reliable and it can handle files of of any site. Now, what makes S3 powerful for web hosting is its versioning feature. When you're working on your website and you're uploading new files, S3 can keep track of all of the previous versions. And this means if you accidentally upload the wrong file or need to go back to an older version, you can do that very easily. It's like having an unlimited undo button for your website files. But having your files stored somewhere isn't enough. We need to make sure users can access them quickly. And this is where CloudFront enters the picture. CloudFront is AWS's Content Delivery Network, CDN, and it's a game changer for website performance. Instead of serving all of your content from one location, CloudFront copies all of your files in data centers around the world. AWS has over 450 points of presence. We call them edge locations across 6 continents, from major cities like London, Tokyo, Sao Paulo to smaller regions as well. And let's look at a real-world example of why this matters. Now, when you're streaming a show on Netflix who use AWS, you're not actually getting that video from one central server. CloudFront's Content Delivery Network means if you're watching in Sydney, you are streaming from an Australian data center. If someone is watching the same show in London, they are getting it from a UK data center. This is why you can stream shows smoothly without buffering, regardless of where you are in the world. CloudFront isn't just about making things fast, it's also a powerful security tool. You can control exactly who gets access to your content using features like signed URLs or cookies. For example, let's use Netflix again, as it's fresh on my mind. You can make sure only paying users can access your premium content. CloudFront also works with AWS WAF, the Web Application Firewall, to protect your website from attacks. WAF watches all of the traffic coming to your site and blocking anything suspicious. Now, setting this up is pretty straightforward. You just connect your CloudFront to your S3 bucket where your content lives, and then AWS handles all of the complex security and delivery parts. Now, getting your content stored and secured is great, but how do people actually find your website? That's where Route 53 comes in, which we mentioned earlier, but it's good to recap so you understand how it all fits in. Route 53 is AWS's DNS service, and its job is to convert your website domain name into actual location to where your content lives. Now, it is smarter than just a simple lookup service. Let's say you are running your website in multiple places around the world for better performance. Route 53 can automatically send users to the closest or the fastest location for them. And you can even use it to split your traffic. Maybe you send 90% of your users to your current website and maybe 10% of your users to a new version that you're testing. When you put these 3 pieces together, S3, CloudFront, and Route 53, you get a complete system for hosting and delivering websites. Your content lives in S3, CloudFront makes sure it's delivered quickly and securely to users anywhere in the world, and Route 53 helps people find it. And what's really powerful about this setup is how well it handles growth. So whether you've got 10 visitors or 10 million visitors, these services automatically scale to handle the load. So you don't need to worry about adding any servers or managing any capacity. AWS handles all of that for you. Plus, you get enterprise-grade features like version control for your files and advanced security features without having to build any of that yourself. Now let me explain part 2 on our AWS journey, running the backend services, or as AWS calls it, the compute layer. This is where your application actually does things, not just display content. This is the business logic. Remember, every application has 2 main parts, the front end and the back end. The front end is what users see and interact with, so your buttons, your images, your text, all of the visual elements. This is what we store in S3 and deliver through CloudFront. But when a user clicks a button or submits a form, something needs to process that information, and this is where the backend comes in. For example, when you're shopping online, there's an add to cart function. The button itself is front end, but processing that action, like updating the cart totals, checking inventory and saving the information, that's all the backend at work. AWS provides 3 main ways to handle these backend operations, and I'm going to explain not only what they are, but when it's better to choose each option. The first and the most modern approach is going serverless with API gateway and lambdas. And when we say serverless, there are still servers. AWS just manages them for you. Imagine that example of an online store that we just mentioned. When a customer clicks add to cart, the API gateway will receive this request and acts as like a receptionist, immediately directing it to the right Lambda function. The Lambda function wakes up, adds the item to the cart, updates the database, and then shuts it down, all in milliseconds. Now with Lambda, you don't pay for any idle time. You only pay for when the function is actually running. This serverless setup is perfect for unpredictable workloads. Maybe your store gets 100 visitors 1 hour and then 10,000 during peak hours on the weekends. Lambda can automatically scale to handle any number of requests. It's also great for specific tasks like image processing, where you need intense computing power, but only for short bursts. For example, when users upload profile pictures, a Lambda function can resize them and generate thumbnails immediately, and then shut it down until the next upload. Serverless is also great for dev teams that just want to focus on shipping features and not worry about the underlying infrastructure. Now, the second option is one of the most fundamental concepts in cloud computing, EC2, Elastic Cloud Compute, and virtualization. This is really the core technology that made cloud computing possible in the first place. Traditional servers are physical machines. You buy the hardware, install an operating system, and run your applications on it. But there's a big problem with this approach. Most of the time, these servers are seriously underutilized. You might be using only 20% of your server's capacity, but you've paid for 100% of it. This is where virtualization comes in, and it's what makes EC2 work. Virtualization lets you take one physical server and split it into multiple virtual servers, each acting like a complete independent computer. Each of these virtual servers can run its own operating system and applications, completely isolated from the others. EC2 takes this concept and scales it massively. When you launch an EC2 instance, you're getting a virtual server in AWS's data centers, and you can precisely select what you need. The elastic part of EC2 is crucial. It means you can scale up or down whenever you need. So if you're running an e-commerce site that gets busy during Black Friday, you can launch more EC2 instances to handle the load and shut them back down when the rush is over. So you're not locked into the hardware that you initially bought, like the physical servers. This flexibility extends to everything about your server. You have complete control over your environment. You choose the operating system, install whatever software that you need, configure the security settings, and you manage it just like you would with a physical server. This makes EC2 perfect for applications that need specific configurations or software that can't run in more restricted environments like Lambda. For example, if you're running a legacy application that requires a specific version of Oracle database, or you need to run a specialized machine learning software that only works on certain operating systems, EC2 gives you that flexibility. Now, unlike Lambda, where you're limited to supported runtime and libraries, with EC2, you can install virtually any softwares or framework that you need, making it ideal for custom applications that have particular dependencies or requirements. Also, with EC2, it integrates so well with other AWS services to make your applications more reliable. So let's dive into what I actually mean. You can distribute traffic across multiple EC2 instances using load balancers. Remember how we talked about ELBs earlier? It ensures no single EC2 gets overwhelmed by spreading the traffic across multiple servers. For example, instead of having just one single server handling all your website visitors, you might have 3 EC2 instances managing all the traffic evenly. Now, the load balancer will send each new visitor to whichever server or EC2 is least busy. AWS also monitors your EC2 instances constantly, and if one of your servers crashes or stops responding, this is what we mean by failed instances. It can automatically launch a new one to replace it, while the load balancer will redirect the traffic to the healthy servers. Your users may not even notice that there was a problem. Now, you can take reliability even further by running your application into multiple availability zones. So if there's an issue in one AZ or one data center, like a power failure or network problem, your application can keep running from the other locations, the AZs. That's what we mentioned before around content delivery network and how you can stream Netflix videos because they are placed in the nearest data center to you for speed. Okay, So what's the trade-off? Well, this level of control and flexibility comes with responsibility. Now, unlike serverless like Lambda, where AWS handles all the underlying infrastructure, with EC2, you are in charge of managing your servers. This means you need to handle things like the operating system updates. Just like your laptop needs constant updates, if you're a Windows user, your EC2 instances also need to be patched and maintained. You are responsible for configuring security settings, monitoring how your servers are performing, and deciding when to add or remove servers based on certain thresholds. But here is why many companies still choose EC2. For applications that need consistent performance or have specific technical requirements, this level of control is invaluable. And that's why EC2 remains one of the most popular AWS services, even with all of the newer, more automated options available. You still get the core benefits of cloud computing. You just pay only for the server time that you use, you can scale up or down as needed, and AWS takes care of all of the physical hardware in their data centers. But you can also get the freedom to configure everything exactly the way you need it, which for many applications makes the extra management work worthwhile. Now let me explain the third way to run your applications in AWS using containers with ECS, Elastic Container Service. The best way to describe this approach from the top is that it sits between serverless and traditional EC2 servers. So containers solve a fundamental problem in software development, the challenge of getting applications to run consistently across different environments. Think about all of the things your application needs to run, specific versions of programming languages, libraries, configuration files, and dependencies. Containers package all of this together in a standardized way. When you create a container, you're essentially creating a complete self-contained package that includes your application code and everything it needs to run. It's like creating a perfectly configured computer that's dedicated to running just your application. Now, this standardization means your application will run exactly the same way, whether it's on your development laptop, in testing, or in a production environment. ECS is then AWS's service for managing these containers. It handles all of the complex tasks of running containers at scale. It can start them up, shut them down, making sure they're running correctly, and automatically replace them at any time. If your application gets busy, ECS can automatically launch more containers to handle the load. Now, this approach really shines when you are building what we call microservices, breaking down a larger application into smaller independent pieces. For example, in an e-commerce application, instead of having one big application doing everything, you might have separate containers for user authentication, product catalog, shopping carts, and order processing. Each of these runs its own container. It can be updated independently and can scale based on its own needs. Now, the beauty of this approach is its flexibility and efficiency. If your product catalog needs more resources during a sale, you can scale just those containers without touching the rest of your application. If you need to update the shopping cart functionality, you can just deploy changes to just those containers. Each piece of your application becomes independent, but still works together as a whole. With ECS managing everything, you don't have to worry about the underlying infrastructure like you do with EC2, but you still get more control over your application environment than you would do with serverless Lambda functions. It's a powerful middle ground that combines the best of both worlds. By the way, seeing as we're focusing on these AWS services, weeks 5 and week 6 inside of my Cloud Engineer Academy are entirely dedicated to AWS, and for a good reason. AWS is the market leader. I've put together over 10 hours of comprehensive AWS video content in these modules where we dive deep into the platform and work hands-on with tools and projects that we've been discussing. And the best part is that it's completely self-paced. I walk you through everything step by step, showing you exactly how to build real-world solutions. And don't worry about it getting stuck. We've got an amazing community of over 350 members who are always ready to help. You can simply raise a ticket whenever you need support. And you'll actually be building with these tools yourself, which is the best way to learn. And since the Academy is self-paced, you can take your time to really understand each concept before moving forward. Link in the description. Let me explain part 3 of our AWS journey, how to store and manage your data. Now, before we dive into databases specifically, I think it's important to understand that AWS offers different types types of storage for different types of needs. Remember how we talked about storing files like images and website content in S3? S3 is what we call object storage. It's perfect for storing files like images, videos, documents, and even your website's code. Think of S3 as a massive, infinitely scalable filing system. Each file in S3 is stored as a complete object and can be accessed directly through a URL. This makes it ideal for storing things that don't need to be modified frequently and are accessed as complete units. You either get the whole file or you get nothing. Databases, on the other hand, are designed for storing data that needs to be queried, updated frequently, and has relationships between different pieces of information. Unlike S3, where you're dealing with complete files, databases let you work with individual pieces of data within a larger structure. They are built for scenarios when you need to search, filter, update small pieces of information, and maintain relationships between different data points. So let's talk about the two main types of databases that AWS offers, because choosing between them is all about understanding what kind of data that you are working with. First, let's talk about traditional SQL, structured query language databases using Amazon RDS, AWS's relational database service. SQL is how we work with data that is organized in tables. Think of it like a very powerful Excel spreadsheet where different tables can be connected, and you can write specific commands to find and update exactly the data that you need. And if you've worked with databases before, you're probably familiar with systems like MySQL and Postgres. There's also another type of database called NoSQL, which we'll cover in a moment, that handles data differently. But for now, let's focus on SQL databases. Think about what running a database normally involves. You need to handle backups, manage security patches, and scale up when you need more capacity, and making sure everything runs smoothly. With AWS, RDS does all of this automatically. You could focus on actually using your database rather than maintaining it. RDS is perfect for what we call structured data, information that fits neatly into tables with clear relationships between them. For example, in an e-commerce website, you need to keep track of how orders relate to which customers, how products relate to categories, how inventory relates to sales. RDS handles these relationships naturally through its table structure and its ability to join data. But sometimes traditional SQL databases aren't the best fit, and that's where DynamoDB, AWS NoSQL database, comes in. DynamoDB is built for speed and scale. It can handle massive amounts of data while still responding in a single-digit millisecond, no matter how big your application grows. So instead of organizing data in rigid tables with fixed schemas, it's more flexible. It's perfect for data that doesn't fit neatly into tables, or when you need extremely fast access to your data. An example is tracking delivery driver locations. Their positions update every few seconds, requiring a system like DynamoDB that can handle frequent changes while providing instant access to the latest data. The really powerful thing about both of these database options is that they integrate seamlessly with the other AWS services that we've talked about. Your Lambda function can easily read and write to either of these databases. Your EC2 instances can connect to them securely, and both databases come with built-in security features to keep your data safe. Now, many modern applications actually use both types of databases together. You might keep your core business data in RDS, where you need strong relationships and complex queries, while using DynamoDB for things that need to be lightning fast, like user sessions or real-time features. Now, the key is understanding what kind of data that you're working with and how you need to access it. If you need complex queries and strong relationships between your data, RDS is probably your best bet. If you need extreme speed and scalability, or if your data structure is more flexible, DynamoDB might be the way to go. And remember, you are not locked into one or the other. You can use both of them to get the best of both worlds. Now that we've got our website running, our backend services are handling requests, and our databases are storing all of the data, it's time to take things to the next level, making your application smarter. And this is where AI and machine learning comes in. And honestly, understanding AI is becoming a non-negotiable if you want to stay ahead in 2025 and beyond. Why? Well, because AI is transforming how applications work. It's no longer just about handling data, but using that data to make intelligent decisions, offering personalized experiences, and automating complex processes. AWS has made it easier than ever to integrate AI into your projects with two key services, Amazon Bedrock and Amazon SageMaker. These tools can genuinely level up what your application can do, and I'm going to break down how. Let's start with Amazon Bedrock. Think of Bedrock as your shortcut to using advanced AI without having to reinvent the wheel. It gives you access to pre-built, state-of-the-art AI models created by companies like Anthropic, Meta, and others, all through a single interface. So instead of spending months building your own AI from scratch, you can go and grab ready-to-go models, customize them, and plug them into your application. For example, say you want to add a chatbot to your application. With Bedrock, you can pick a pre-trained model, train it on your company's data, like your product info or FAQs, and voila, you've got a chatbot that understands your specific business context. And it's secure too, because all your data stays within your AWS environment. Now, something cool about Bedrock is that it has a feature called RAG, Retrieval Augmented Generation. This means that AI can pull real-time data from your own databases while answering questions. So imagine your chatbot not only chatting naturally, but also giving up-to-date minute answers about whether a product is in stock or the status of a customer's order straight from your backend systems. Now, if you are the type who wants full control and is ready to dive deeper into AI, Amazon SageMaker is for you. SageMaker is basically like a fully equipped workshop where you can build, train, and deploy your own machine learning models. SageMaker is perfect if you want to do things like predicting user behavior, detecting fraud, or recommending products. Let's say you want to predict which customers are likely to buy certain products. You start by exploring your data in SageMaker, maybe pulling customer activity from DynamoDB. Then you train your model to recognize patterns in that data, like which users tend to buy based on their browsing habits. Once the model is trained, SageMaker makes it easy to deploy it. So if you need real-time predictions, like instantly recommending a product, SageMaker can set up the endpoint to handle that. And if it's more about running predictions in bulk, like generating a report, SageMaker can handle batch processing too. You only pay for what you use, which makes it flexible and cost-effective. Now, AI matters more than ever because it's what separates modern dynamic applications from those stuck in the past. Think about how applications and services are evolving. For example, e-commerce platforms are using AI to recommend products and predict what customers might want to buy next. Social media platforms use AI to show you posts and ads that you're most likely to engage with. Logistic companies are optimizing delivery routes with AI to save time and fuel costs. Healthcare applications are using AI to predict patient risks based on historical data. If you're building applications for 2025 and beyond, understanding and implementing AI will be one of the most important and valuable skills that you can have as any kind of engineer. And the best part, both Bedrock and SageMaker integrate seamlessly with the AWS infrastructure that we've already set up. They can pull data from DynamoDB or RDS, be triggered by Lambda functions, or work alongside your EC2 instances. This means you don't have to reinvent your application's architecture. You can layer AI on top of what you've already built. For instance, you could start small, adding an AI chatbot with Bedrock to improve customer service. As your needs grow, you might use SageMaker to develop a recommendation system that learns from customer behavior over time. And step by step, you can evolve your application into a system that not only handles data, but actively learns and adapts to your users' needs. Now, we need to shift to the most important part of this course, and that is security. With all of these powerful tools, EC2, S3, DynamoDB, Bedrock, they offer incredible possibilities, but they also come with responsibilities. Protecting your applications and data is not optional. It's fundamental to everything that you build in the cloud. And cloud security is in extremely high demand right now, and for good reason. As businesses move to the cloud, modernize their environments, the need for security experts who deeply understand the nuances of securing cloud environments has grown significantly. However, the availability of these skilled professionals hasn't kept up, creating a major gap in the industry. The reality is, every piece of your architecture, whether it's where you store your data, how you handle requests, or how you implement AI, needs to be designed with security at its core. The cost of failing to do so is just under $5 million per data breach, not to mention the long-term impact on customer trust. In my experience, I've seen organizations build and launch applications without thinking about security until something goes wrong. And this approach is risky, especially in cloud environments where security isn't just about managing a firewall. It's about deeply embedding protections into every service that you use, from the moment you start building. And this is why I decided to specialize in cloud security. The cloud requires a proactive approach. And in AWS, there is two main services that form the backbone of cloud security, and these are the ones that every engineer must know: VPC and IAM. Let's start with Amazon VPC, Virtual Private Cloud. VPC is your own private section in AWS's cloud where you control exactly how your application's networking works, what can connect to what can access to the internet, and what stays private. Inside of your VPC, you can organize your network using what we call subnets, which we mentioned earlier, but let's do a quick refresher. You've got two types of subnets: public and private subnets. Public subnets are where you put your resources that need to communicate directly with the internet, like your web servers that need to accept incoming traffic from users. Private subnets are for resources that should never be directly accessible from the internet, like your databases or your internal services. But what if your private resources need to access the internet, say for software updates or to download packages? This is where NAT gateways come in, the network address translation. Think of a NAT gateway as a secure bridge. It sits in your public subnet and allows your private resources from your private subnets to reach out to the internet when they need to. But, and this part is very crucial, it never allows incoming connections from the internet to reach your private resources. It's a one-way street for internet traffic. To control traffic in your VPC, AWS gives you two powerful tools that work together: NAT calls, network ACLs, and security groups. Now, each serves a different purpose, but they complement each other perfectly. Network ACLs or NAT calls act as a firewall for the entire subnet. They let you create rules about what kind of traffic can enter and leave the subnet as a whole. For example, you might use a NAT call to block certain types of traffic from even reaching your subnet in the first place. Security groups work at the individual resource level. They are like the firewall for each specific instance or service. They let you control exactly which traffic can reach each resource and what that resource can communicate with. For instance, you might have a security group for your web servers that only allows incoming HTTP and HTTPS traffic and lets those servers only communicate with specific database servers. And here is how this all works in practice. When someone visits your website, they connect to your public-facing servers in the public subnets. But when those servers need to access your database or AI models in the private subnets, that communication happens entirely within your private network. This means even if someone managed to compromise your web server, they wouldn't automatically get access to your sensitive backend systems. And the other crucial piece of the security puzzle is IAM, Identity and Access Management. While VPC controls network access, IAM controls who can access what within your AWS environment. It's based on a simple principle: give everyone exactly the access that they need and nothing more. With IAM, you can be incredibly precise about permissions. Let's say you have a Lambda function that needs to use a Bedrock AI model to analyze customer feedback. You can create an IAM role that allows that specific Lambda function to use that specific AI model, but nothing else. You can do the same with EC2s. Your database backup process might have permissions to read from your database, but not to modify it. Each piece of your applications gets exactly the permissions that it needs to do its job, no more and no less. Now, this granular control is especially important when you're working with AI and machine learning services. These systems often process sensitive data, and you want to be absolutely certain that this data can only be accessed by the specific components that it needs. IAM lets you enforce these restrictions at a very detailed level. So when you put all of this together, you got multiple layers of security. Your VPC isolates your entire network, public and private subnets separate your internet-facing resources from your internal ones. NAT gateways gives your private resources controlled internet access when needed. Network ACLs protect traffic at the subnet level. Security groups provide detailed control at the resource level. IAM ensures that every component only has the permissions that it absolutely needs. And this layered approach is what we call defense in depth. If an attacker somehow gets past one layer, they still need to deal with all the other ones. Your EC2 instances, Lambda functions, databases, and AI services all work within these security boundaries that you define. Remember, in cloud, security isn't optional and it isn't something that you add at the end. It needs to be part of your architecture from the very beginning. By implementing these services effectively, you create a secure foundation that lets you build build with confidence. That said, AWS offers other crucial security tools as well. Services like GuardDuty for threat detection, KMS for encryption key management, and AWS Shield and WAF for protection against cyber attacks. And by the way, when you join my Cloud Engineer Academy, there's a whole dedicated week on cloud security, and of course, that is my specialization, so you can learn directly from me, someone who's building with these tools directly and understands them inside out. Link in the description. So let me walk you through the final piece of running applications in AWS, monitoring and auditing. You know, after everything that we've built, the storage, the compute, the AI services, and all of that security, we need to know what is actually happening in our environment. And this is where CloudWatch and CloudTrail come in. Let me explain each one because they serve different but complementary purposes in maintaining and managing your AWS environment. CloudWatch is AWS's primary monitoring and observability service. Think about all of those services that we've discussed, your EC2 instances, your Lambda functions, your databases and AI models. CloudWatch collects operational data from all of them. It gathers performance metrics, logs, and events from your AWS architecture and infrastructure. In the real world, this means you can see exactly what is happening in your applications. In practice, when you're running a production application, CloudWatch lets you see exactly what is happening across your entire system. You can create dashboards that show your most important metrics and set up alerts that notify you when something isn't working as expected. For instance, you might want to know when your API response times are getting too slow, or when your database is running out of connections, or when your Lambda function are experiencing errors. CloudWatch can also trigger automated responses to these conditions. If your application is experiencing heavy load, CloudWatch can automatically initiate scaling. If a service is failing, it can trigger automated recovery processes. This automation is crucial for maintaining reliable applications at scale. Now, while CloudWatch is keeping track of how everything is performing, CloudTrail is doing something different but equally important. It's recording every single API call made in your AWS account. That means anytime when someone makes a change, CloudTrail logs it. Remember those IAM roles that we talked about? CloudTrail tells you whenever someone modifies them. Those VPC configurations that we set up, CloudTrail logs any changes to those. If anything in your environment changes, CloudTrail tells you exactly what changed, when it changed, and who changed it. This becomes specifically crucial when you're running AI and machine learning workloads like we discussed with Bedrock and SageMaker. You need to know how your models are performing, whether they're using resources efficiently, and who's interacting with them. CloudWatch gives you the performance metrics, while CloudTrail provides you the audit trail. When things go wrong, and trust me, in production systems, things will eventually go wrong, having both CloudTrail and CloudWatch is invaluable. CloudWatch shows you the operational impact, while CloudTrail helps you track down exactly what changes might have caused the issue. This monitoring and auditing capability is really the final piece that brings everything together, and it gives you the visibility that you need to control and run production applications with confidence, knowing that you can track, debug, and resolve issues quickly when they arise. And if you want to learn how to go from zero to landing your first cloud job in just 90 days, then go check out this video where I share my step-by-step roadmap that I use to break into cloud.